This is question 3139. We have a pipe surrounded by a flange. We assume steady state 1D constant properties, no radiation. Flange profile symmetrical to circular fins of rectangular profile, so we can pull the equations from table 3.3. If we need to find the base temperature of the flange and the heat loss, we equate the heat loss for the pipe is equals to the heat loss for the fin. We use that to solve for the base temperature, and for using base temperature, we solve for the heat loss and we find out our variables. Question 197. We have a cylinder here. We're asked to find the heat loss and plunge temperature variation of a single fin for conditions A, B, C, and D, which is the infinitely long fin, the adiabatic fin, the specific temperature, and the convection. All this, the plot is in Excel attached. Question 3202. We are asked to find, we have a circuit board and we're asked to find T1 and T2, the surface temperature of two sides of circuit board, and then B, T1 and T2, the new temperatures of the two sides of the circuit board. And we assume steady state 1D constant properties and no radiation. So we use the resistances to find Q1 and Q2, that is part A. And then for part B, for the total heat loss, we need the finned and the unfinned heat loss. We add them together, we get the base temperature. And here, we use that to get T1 and T2. This is T2, and then that was T1. There were many points in this problem where I didn't understand. For example, problem 3197 here. In Excel, I really struggled with doing the Bessel functions, and when I plotted my graph, part D was not really matching up with the solutions. For question 3202, I struggled with understanding all of the resistances. For example, for the aluminum and the epoxy was very hard to think about, and also for the finned and unfinned part of the heat. Question 1, I did not really understand why we needed to find the effectiveness, and I didn't know why we had to find the efficiency from the table, from the figure. Even though we can calculate that, I'm assuming that that's just a second way to find out from the figure, but I'm not very confident with that.